In this video, we will be discussing the example problem. We are talking about example 2.7, and this is related to the elevation in boiling point. So we have 18 grams of glucose is dissolved in C₆H₁₂O₆ is dissolved in 1 kilogram of water in a saucepan. At what temperature will water boil at 1.013 bar? And we have the kb of water, which is given as 0.52 Kelvin kilograms per mole. So first we'll start with writing down what's been given to us. Always another good thing to do is you can just write it down as to what's been given and what you need to calculate, and that usually helps you figure out, okay, how do I do this problem? Okay, so we've been given the following things. First of all, the mass of C₆H₁₂O₆, which is glucose, and this has been given as 18 grams of glucose. The next one is mass of H2O, which is equal to 1 kilogram. Okay, we've been given kb of water, so kb of H2O equals to 0.52 Kelvin kilogram per mole. And the last one given to us is the pressure. I'm pretty sure we won't be using it. Maybe not. Okay. Sorry, that handwriting is super bad. So pressure is given to us, and that's 1.013 bar. Now, what do we need to calculate? They've asked us the temperature at which water would boil. Normal circumstances, you would just say 100 degrees Celsius. But right now, we have something added to the water which will lead to the elevation in boiling point. So we need to figure out the value of the boiling point of water at in this solution, basically. So first of all, essentially we are going to be calculating the boiling point of the solution. Okay, based on all of these values, we know that we can calculate the value of delta TB. From delta TB, we can calculate the value of the boiling point of the water of this solution. Okay, so first of all, we need to calculate the number of moles of glucose, because we need the molality. So we know delta TB equals to M into Kb, or Kb into M. So we have the value of Kb given over here. We need to calculate the molality of the solution. So for that, for the molality equation, molality will be equal to number of moles divided by the mass of the solvent. Pretty sure this equation is right, but I am going to double check that one really quick. Also, let me know if writing it, if videos like these are easier to understand. I don't mind going back to the whiteboard. This just saves me so much time. So yeah, so the molality equation is number of moles of the solute divided by mass of the solvent in kilograms. I cannot believe that when I was in 12th grade, I wasn't able to remember this, but now I just can. Anyways, so we start with calculation of the number of moles of our solute. So the number of moles of solute is going to be, you need to calculate the molar mass. Molar mass of C₆H₁₂O₆. Basically, you just need to total. I'm assuming you know how to do that. We just need to total the mass of all of the individual ones in like these atoms, and then it gives us. So essentially, it's going to be 12 into 6 plus 12 into 1 plus 16, right? Yeah, 16 into 6. So this will give us the molar mass of 15.916, right? 16 into 6, and this gives us the molar mass of glucose, which is 180 grams per mole. Okay, so we can calculate the number of moles of glucose, so C₆H₁₂O₆ equals to mass, which is 18 grams divided by molar mass, so 180 grams per mole. Now this gets cancelled, mole goes to the top, and then this gives us 0.1 moles. Okay, so from here we're able to calculate the molality. So molality of the solution will be equal to number of moles of the solute, so 0.1 moles divided by mass of the solvent in kilograms, so 1 kg. So this is equal to 0.1 moles per kilogram. Going to scroll down so that, oops. This is the molality. Now delta TB equals to M, which is the molality, so 0.1 moles per kg into the Kb, right? So that's going to be equal to 0.52 Kelvin kilogram per mole. Now, first of all, if you've watched like some of my videos, you notice that I always like to tackle our units first, and now we are left only with Kelvin, which is good because we need the value of delta TB. So delta TB is going to be equal to 0.052 Kelvin. So this is the difference in boiling point. Okay, now we know that the boiling point of water is equal to 373.15 Kelvin at 1.013 bar. Okay, that's why. So this is an atmospheric pressure. The boiling point of water is 373.15 Kelvin. Now, delta TB equals to TB minus TB naught. Okay, and TB will be equal to delta TB plus TB naught, where TB naught is going to be the boiling point of the pure solvent and delta TB is the change in the boiling point. So delta TB we've calculated is 0.052 plus 373.15 Kelvin. And this, when we total, we get 373.202 Kelvin. So basically for this question, we were asked to calculate the boiling point of the solution when we add 18 grams of glucose to 1 kilogram of water. We first started with calculation of the molality, and from the calculation of molality, after that we were able to calculate the value of delta TB using the value of molality as well as the value of Kb, which was already given to us. Then we just use the we know that water's boiling point is 373.15 Kelvin at 1.013 bar pressure. And we use the equation of the elevation and boiling point. And we're able to calculate the value of the boiling point of the solution. Of the water in this solution. So that is 373.202. With that, we're done with example 2.7. In the next video, we'll be talking about example 2.8.